Hello everyone. In this lecture we will be learning about three-phase control rectifiers. We will be discussing about three-phase full wave control rectifiers. The circuit of full wave control rectifier is almost same as the circuit of full wave control rectifier, only the diodes have been replaced by SCRs. We have 6 SCRs in place of 6 diodes. Now we can see that the naming of the SCR are very important. This is SCR 1, this is 3, this is 5, and this is 4, this is 6, and this is 2. This naming will be important when we actually discuss about the working procedure of this control rectifier. In case of control rectifiers, three-phase control rectifiers, the switching will always be continued for 180 degrees. That is, each of the switch, let it be G1, G2, G3, any of the switch will remain on for 180 degrees and will remain off for rest 180 degrees. Now, since switching is fixed or the switching duration is fixed, where does this firing angle alpha come into action? The firing angle alpha is the angle at which the switch number 1 is fired at. So here alpha is equal to 60 degrees. At 60 degrees switch number 1 is fired and switch number 1 remains fired for 180 degrees. And after again, since alpha is after next 60 degrees switch number 2 is fired, and after next 60 after 60 degrees switch 3 is fired. After 60 degrees switch 4 is fired. In case of switch 4, we see here we have this 120 degrees, and the rest, since these waves are sinusoidal and periodic, the rest will come from the beginning. And again we have 60 degree here and 120 degree here for group switch 5, and for switch 6 we have 60 degree starting right from the beginning. And when we see the voltage sources, we are considering line to line voltages. Here if we see the legend, this is VAB, this is VAB, this is VBC, this is VCA, and now since this is VAB, the minus of it, the dotted line here is VBA, and this is VBC, minus of it is VCB, and this is VCA, so minus of this thing over here, dotted line, is VAC. Now one thing is to be observed here, that when the for first 60 degree of operation, switch number 4, 5, 6 are on simultaneously. In the next 60 degrees we have 5, 6, 1. In the next 60 degrees we have switch number 6, 1 and 2 on. 6, 1, 2 on. Again in the next 60 degree we have 1, 2, 3. Next 60 degrees 2, 3, 4, and next 60 degrees we have 3, 4, 5. These numberings will be important again when we discuss how actually the thing works. So we can see from when alpha is from 0 degree, when the voltage wave shape for 0 degree to 60 degrees is considered, we have already seen that switch number 4, 5, 6. These 3 are turned on. Now if we remember right, here we have switch number 5, here we have switch number 4, and here we have switch number 6. These 3 are turned on and short, and all the others are off. Now since only these 3 current paths are there, the output voltage can either come from current will come from VC, go here, take this direction, go through the load, and it will have an opportunity to go to VB through this path or go to VA through this path. Now we have to think which path will it take to return. Now the output voltage can either be, since the current starts from VC, the output voltage can either be VCB or it can be VCA. If we see at the voltage curve, we see that for the first 60 degrees, this is the curve for VCB here, and the VCA curve is this. So we can see that VCB is greater than VCA. As a result, the output will follow the shape of VCB for the first 60 degrees. From 60 degree to 120 degrees, switches 5, 6 and 1 are active on. So here we have switch number 1, here we have switch number 5 and here we have switch number 6. Now these three are on. So current can either go from VA back to through here back to VB, or it can go from VC through the load back to VB. So the voltage output can either be VAB or voltage output can be VCB. There is only one return path, but the current may go from VA or VC, any of the node. So the voltage output can be VAB or VCB. Now for the next 60 degrees from here to here, we have this as VAB and VCB. VCB is this line, red line. So as a result, we can see that VAB is greater than VCB and output will follow the path of follow the wave shape of VAB. Now next 60 degree, again we have switch number 6, 1 and 2 active. Switch number 6 is here, switch number 2 is here and switch number 1 is here. As a result, current can only start from VA and current can return to VB or VC depending on which voltage is greater. So we have two voltages which will be used, VAB or VAC. Now in the third half from 60 degree from 120 degree to 180 degree, this voltage or we are considering VAB and VC. So VAB is AB is this one and VAC is this dotted one. This is VAC and this is VAB. So we can see that VAC is greater than VAB. As a result, the output will follow VAC. From 180 degree to 240 degree, similarly we have switches 1, 2 and 3 active. Here we have switch 1, here we have switch 3 and here we have switch 2. These three are active. So the voltage in action are VAC or VBC. Now from here to here we can see that VAC is this dotted line, this is VAC, and VBC is this line, VBC, and we can see that VBC is greater than VAC. As a result, the output follows the same wave shape as VBC. For the next 60 degrees, we can see we will see that switches 2, 3 and 4 are on. Here we have switch 2, here we have switch 4 and here we have switch 3. As a result, the current can start from VB and it can either return to VC or VA depending upon which switch remains active. Now we have two voltages, VBC and VBA. From 240 degree to 300 degree, VBC is this solid line and VBA is this dotted line. So it is very apparent that VBA is greater than VBC and it is following the wave shape of VBC. For the next 60 degrees, we can again see that in the next 60 degrees, the switches that are on are 3, 4, 5. Since 3, 4, 5 are on, this is 5, this is 3 and this is 4. As a result, the voltage applicable are VBA and VBA and VCA. These two voltages are applicable and it is clearly seen that VCA is greater, and as a result for the next 60 degrees we have VCA. One thing is to be noted that at no point of time the output voltage falls below 0 volt. Since it is a rectifier, if it were a case that the output voltage would fall below 0 volts, that is if the output voltage would be something like this, it would be clipped at 0. We have to remember this. This phenomena does not occur if alpha is equal to 60 degree, but if the value of the alpha is changed from 60 degree to 90 degree, that is if the firing angle changes, this phenomena will occur and we will have to take this into consideration. We can see that the wave shape as seen in the 3-phase control rectifier when alpha is equal to 60 degree is same as the wave shape we can see in a three-phase uncontrolled rectifier. So the VDC will be equal to 3V line to line divided by pi. VRMS will also be equal to VRMS of uncontrolled rectifier. I have given you all an assignment to find out the VRMS of uncontrolled three-phase rectifiers. So I am not showing the derivation here. You will be doing the derivation in your assignments. Thank you so much. That's all for now. In the next part of the in the next lecture, we'll be seeing another case of three-phase control rectifiers. We will see how changing the firing angle alpha we can actually change the output voltage. Thank you.